calculus kids, this is Dr. Callahan with Week 9 Friday. How are you guys doing? Go ahead and answer the following 3 questions. Today, your warm-up blog is due, so if you're doing this at home, just follow along and then just make sure you turn this in to me on Monday when I see you in person, so that way I can update your warm-up blog. All right, as you guys know, Pi Day is definitely approaching, and here are some statistic facts about Pi and why we celebrate it. And if you know about pi, it is basically the ratio of the circumference of a circle to the diameter. And in 2004, Daniel Timan actually recited 22,514 digits of pi after 3.14, which is pretty impressive. And so with that said, let's go ahead and get started with your warm-up. So you need to go ahead and flip over to the very back of the page of your warm-up. It looks something like this. And it asks you a series of questions. And so first things first, I want you guys to go ahead and tell me how many boxes did you fully fill out. So just count the number of boxes and it should be out of 100. Next, out of 100 points, give yourself what you think you should deserve from 0 to 100 of your participation in my class for the last 9 weeks. Participation is for things like not being tardy or absent in class and participating in class, anything that you do, you're working on. Next is preparation. Preparation comes for putting your cell phone away, you have your warm-up log and your white packet out, and you're essentially prepared for class. All right, and when you're done with this, make sure you guys fill out the packet. It does ask you a few reflective questions, so make sure you guys have that done, and then just give it to me the next time I see you. All right, so today we are going to continue on our third day on differential equation and separation of variables, and we're going to start off with some questions from your textbook. Now, if you are at home, you don't have this, but you can just go ahead and copy down the questions itself. This is not in your white guided notes. Unfortunately, I just actually recently added this. And we're going to go ahead and go over the first question. And these questions are directly from your warm-up. I'm sorry, from your textbook. So take a moment and read question number 21. Okay, so let's go ahead and take a look at this. So it's given to you that the change of y, so rate of change is obviously dy over dx, or just y prime. So y prime is proportional to y. So that's going to be a k times y. When x equals 0, y is 4. Okay, my pen is having a little bit of difficulty here. That's okay. I'll just try to grab a different one. So 0, 4. Seriously, this is not working at all. Let's see. There we go. We'll just use a different pen. And then it's also given to you that when x equals 3, y is 10. Find the value of y when x equals 6. So I'm going to put a question mark right there, although that looks like a 2. So we're just going to put a question mark. There you go. All right, so looking at this right here, we're going to go ahead and rewrite the y prime as a dy over dx equals k times y. I want to go ahead and separate the differential equation. I want the y on the left side, the x's on the right side. So I'm going to multiply by x on both sides and then divide it by y on both sides. So then the x cancels. I have a dy 1 over y equals y cancels k times dx. Let's go ahead and integrate this. You know the integral of 1 over y dy is just going to be ln y, which is equal to the integral of k, which is kx plus c. Now, if you want to get rid of the ln, I'm going to go ahead and put an e on both sides. E and ln cancels, so y equals e to the kx plus c. Now, remember I said that you could always bring that c down. Now, the reason for that is, remember in Algebra 1 with the rules of exponent, if you have a to the third times a to the sixth, it's the same thing as a to the third plus 6. Right? So if you have something that's going to be e to the kx that plus c, that's the same thing as e to the kx times e to the c. Well, e to the c is just going to give you a constant. So you can actually bring that constant to the front. So it's just ce to the kx. And that's a rationale behind that. So we're just going to go ahead and rewrite this as y is equal to ce to the kx. And there's your formula. All right, so now that I have my formula right there, I'm going to use my first point to find c. So I'm going to have 4 is equal to ce to the k times 0. And as you guys know, k to the 0 is just 0. You know that e to the 0 is just going to be 1. 1 times c is c, so c is equal to 4. So once I have this, I'm going to go back to my original equation, replace that c with 4. So y equals 4e to the kx. Now I'm going to use my second point to find k. So let's plug it in. 10 equals 4e to the k times 3. I'm going to divide it by 4 on both sides, so I have 5 over 2 equals e to the 3k. I'm going to put an ln on both sides, get rid of the e and also to bring down the 3k. So I have 3k equals ln 5 over 2. And lastly, I want to divide it by the 3. So ln 2.5 divided by 3. Now, if you have your calculator, you can go ahead and plug that in, and it should give you a decimal, but that is what your k is. So then again, I'm going to take that k, plug it in right here. So my equation now has c, which is 4. It has k, which is ln 2.5 divided by 3, and then x. So now that I have this equation and it's completed, I can go ahead and move forward to finding what y is when x is 6. So y is equal to 4e to the ln 2.5 divided by 3 times 6. Now you could reduce this, so that's a 2. So y equals 4e to the ln 2.5 times 2. And if you go ahead and plug that into your calculator, you will have a 25 for y. And that is your answer. All right, let's take a look at number 23. So go ahead and read number 23. So it's asking you to find the rate of change of v, which is proportional to v. So it's given to you that you have your t as your x, v as your y. It does give you 2 set of points. So when x is 0, the volume, I guess, is 20,000. When the t is 4, you have 12,500. So it's asking you if t is equal to 6, what is v? So the rate of change of v is equal to k times v. So changing the v prime, dv over dt is equal to k times v. Now I want to go ahead and separate it, so that way I have dv divided by v on the left side, multiply dt on both sides, k times dt. Now let's go ahead and integrate both sides. The integral of 1 over v, and you guessed it, is ln v. The integral of k is just k, it's just going to be k t plus c. I was going to put like kx, but I'm like, well, what is x? Remember, x is t, y is v. So if you have to write it down and remind yourself, that's totally fine. V is y. So my goal here is to solve for y. So I'm going to go ahead and put an e on both sides. That cancels. V is equal to the e to the kt, and the c, just remember, comes in front of that. So now that I have my formula, I'm going to use my points to find c. Your first one is 0 and 20,000. My goal here is to find c. So I'm going to have 20,000 equals ce to the 0. So that just means c equals 20,000. So let's go ahead and rewrite my equation again with c. V equals 20,000 e to the kt. Now I'm going to use my second point to find k. So I have 12,500 equals 20,000 e to the k times 4. Divided by 20,000 on both sides. And at this point, because the number is so much bigger than the previous example, you can't really put like a 2.5 in decimals because you know it's a 5 over 2 from the last example. This one you would just have to put into a decimal. So if you divide it, you should have a 0.625 equals e to the 4k. Then we're going to do a ln of both sides, which e and ln cancels. And then lastly, divided by 4. So then I have my ln 0.625 divided by 4. Now that I have this, I can put it back into the original equation, or actually it should be this one here. So then I have my v is equal to 20,000 e to the ln 0.625 divided by 4 t. All right, we're almost there, you guys. So last point, if x is equal to 6, or not x, but t, if t is equal to 6, what is v going to be? V is going to be equal to 20,000 e to the ln 0.625 divided by 4 times 6. And if you plug this into your calculator, your answer should be a 9882.118. And that is your answer. All right, you guys, let's go ahead and take a look at the next example. Here we go. Go ahead and read it. Okay, so it has a half-life, rhodium does, of 1,599 years, given that after 10,000 years, there's only 0.5 grams remaining. Find the initial quantity and amount after 1,000 years. Okay, so looking at this right here, it's given to you that one of the points was after this many years, you have 1/2 of the initial quantities remaining. I do know that at 0 years, this is the amount that I have. So let's go ahead and set this up. Y is equal to CE to the KT. So let's go ahead and take a look at this. So my first goal here is I'm going to have to go and find K. So looking at this part here, I'm going to have Y, which is going to be 1/2 C equals CE to the K times T. And your T is 1599. And the reason why we need to find K first is because you have C's right here, which means they're going to go ahead and cancel each other out. And so that's why we have to do K first. So in this situation, your C's cancel, and you're just left with 1/2 e to the K 1599. You want to do the ln on both sides. So you have the ln 0.5 equals ln and the e cancels, 1599K. So your K is going to equal to ln 0.5 divided by 1599. And that is your K. So you found K first. Now you're going to go ahead and plug it into your equation. Y is equal to CE to the ln 0.5 divided by 1599 T. Next we're going to do is going to look at the following point to find C. And if you look at the following point for C, let's see here. We're going to be using the point that's given to us that is at 10,000 years, only 0.5 remains. So first thing is years, so that's going to be 10,000, and then 0.5 grams. Okay, so remember that this is going to be years and the quantity that remains. So we're going to use this point to find C. So 0.5 is equal to CE. And if you do the ln 0.5 divided by 1599 times 0.5, if you plug that into the calculator, you'll have E to the 0.13103. So then let's go ahead and do the ln of both sides. Or I'm sorry, you know, if you did E to this power here, you wouldn't need ln because you don't have any variables on the exponent here. You just plug in E to the ln 0.5 divided by 1599 times 0.5. You will have 0.13103. Lastly, let's just divide that on both sides. So what is 0.5 divided by 0.13103? You should have C equals 38.158, and that is your answer. So once I have that, I'm going to plug it back into this equation here. So then Y equals 38.158, which is your C, E to the ln 0.5 divided by 1599 T. Now that I have this equation, and this is my equation, I can now answer the following questions that it's asking me. Find the initial quantity and the amount after 1,000 years. So what it's asking me to find is after 1,000 years, what is the quantity? Because remember, years is first, quantity is the second part. Okay, so let's do that. So your X is going to be, or T, excuse me, is going to be 1,000. Your goal is to find the Y, which is a quantity. So let's plug that in. Y is equal to 38.158 E to the ln 0.5 over 1599 times 10,000 or 1,000. So plug that into your calculator, and you should have a 24.736 grams, which is your answer.